Welcome to the Medical Device Innovators Podcast. I have with me today two guests. I have Kerim Genc and Rebecca Bryan, both from Synopsys, and we're going to be talking about the industry as a whole, as well as a little bit about what Synopsys does and how they help in that innovation side of medical devices, as well as some of the technologies that we've come up with over the years. But to start with, Kerim, why don't we start with a kind of a background of how did you end up here and kind of what's your training and where do you go from there?
Sure. Well, thanks, Arlen, for having us. A bit about myself. I'm originally from Calgary, Canada, in Western Canada, and I started off my university career wanting to be the sports physician for the Calgary Flames. But about halfway through undergrad, I realized med school wasn't in my future, and I started volunteering at the Human Performance Lab. So it was a biomechanics lab at the University of Calgary. They did a lot of research R&D for the Canadian Olympic Committee. Adidas was a big funder of some of the research that they did there for footwear biomechanics, and I got into that. And ended up at Penn State doing my master's, and then eventually my advisor moved to the Cleveland Clinic, where I started my PhD at Case Western in biomedical engineering, and my focus was on bone loss in space and how when astronauts fly in space, they lose bone due to disuse. And I was using a software to look at CT scans of astronauts, and that was Simpleware. And I think I bothered support enough that they knew who I was. And then I saw a posting for a small company in the UK called Simpleware that wanted to start an office in the US. So I applied, and my colleague Becky here is the one who hired me back 11 years ago now. And so I straight out of my PhD, I worked for Simpleware. My instructions were US, Canada, go. Was about it. No sales background, no business background. I just kind of got thrown in. And fast forward to 2016, I'd been managing sales business in the US. We got acquired by Synopsys, and I continued on that role. I ended up managing the global sales for a while, and just recently moved to a product manager role, more on vision, strategy, partnerships, things of that nature, as well. So that's how I ended up here.
Okay. And Rebecca, I guess it's a similar journey, or how did you get your start?
I could spin the same line, but slightly different. I started off wanting to work in Formula One. I was really keen on motorsport. So I went into mechanical engineering as an undergrad and a way of doing that. And then in my final year, I did a biomechanics module and decided it was really fascinating and absolutely loved that interface between medicine, humans, and engineering. And I just found it really interesting. The easiest module I had to study for in the whole of my degree. So I loved it. And I decided that would be a really good thing. And my PhD supervisor, as he became, convinced me that you had to do a PhD to work in this field. I think he had a bit of an ulterior motive involved in that. He encouraged me. I had a fascinating PhD with him, looking at generating virtual populations, really using statistical modeling to look at modeling hip implants, but the methodology could be used for anything. So that was really good. And it was one of the early papers in that field. And my supervisor was great at taking me out and introducing me to people, going to conferences. So I built a network through that time. And I came across Simpleware as a company that sounded quite interesting to work with and a part of the UK that I wanted to work in. And so, I applied for the job and became an engineer with them. And very quickly, they realized that I didn't mind talking to people. So I got pushed into more of an outward role, hence being out meeting Kerim and doing training and teaching. So I sort of moved that way and then moved further and further into a sales account manager role. And then quickly backed out of that again after a few years. And I'm now also in a product manager role, having been through most of the areas of the company apart from actually writing code, which I think is a really interesting opportunity to have had. My focus now is on in silico clinical trials and in silico medicine. which is really fascinating. And again, puts me in that sweet spot of really that interface between engineering, math, science, and clinical applications.
And we'll definitely dive into in silico here in a minute, because I'm sure that's a term that a lot of people have not heard or have heard just in passing. But before that, what really jumps out to me is both of you have kind of a technical background, but we often think of sales and outreach and things like that as a separate role that's not really related to the technical training. Have you found that your science and STEM kind of based backgrounds have been a benefit in that side of things?
Absolutely. I found myself as a translator. So I've been able to communicate between your end user and your developer and your engineer within the office. And I'm the go-between, and it's a really great position. And when you really understand what the customer needs, speaking almost one language, and then you translate that through to the developer and say, this is what we need it to do. And then you see that product or that solution evolve. It's very satisfying.
Yeah. And I think, going through the PhD process, I remember especially some customers, it was, almost like a dissertation defense. When they start peppering you, they think, oh, who's this sales guy? Let me see if he knows what he's talking about. So, to echo what Becky says, just having that technical background, being able to speak the same language at the same level as folks who you're selling to, because in our area, it is typically, R&D, very technical within groups. So most of the people you're talking to have PhDs themselves. So it definitely, having that technical background certainly helps. But that being said, it's also good to have diversity within your team. We do have especially one of our account managers his background is pure sales. He does not come from a technical trading background, but he picked it up over time. He sold simulation software for a long time and joined us. And so also getting his perspective is very, very useful too. He kind of gets us to back out of the technical weeds a bit, because that is kind of our safe spot. So you do learn over time with sales that you kind of try to go to the technical when it's appropriate, but learn how to kind of pull back a bit and not dive too deep.
The other thing that jumps out to me is that no one intended to kind of go into the medical device side of things. For me personally, it's I was going to go build rockets and work for NASA and things like that, and ended up in medical devices as well. So whether it's Formula One or working as the sports physician for hockey, I feel like that's kind of an indication that on the education side, we don't really expose a lot of students to the medical side of things. I mean, my background is also mechanical engineering, and it always seemed to be talking about automotive or power plants or aerospace or things like that. But for a long time, we didn't really speak too much about that there was this career opportunity on the medical side that was above and beyond. You don't have to be a doctor to work in this career. Well, I guess a physician. I mean, talking to a bunch of people with PhDs. So yeah, I mean, at some level, there's there's definitely a need for the the graduate school side of things. But
I think it's important to give what I kind of stumbled into it. So just having, I was lucky, during my undergrad, I remember looking at the end of the hall, the human performance lab. I was always wondering what's going on in there, and just going and exploring. I just walked into a professor's office and said, can I volunteer this summer? And it just started from there. And then even at the end of my PhD too, I realized too that, my advisor, he'd be great to get me a postdoc position somewhere doing research, but he doesn't, his job is in industry. So it's up to me. Like, I met Becky at a conference, and, you just have to go out there and just meet people without an agenda and just interact, and then you kind of stumble into these things and you find it, and it just kind of aligns with what you want to do.
Yeah,
for sure.
I'd go with that. Building your network is really important, and that's a friendly, fun thing to do. And you just end up knowing people all over the place. And the more people you know, the more interesting ideas and interesting knowledge you get from them about what they're doing and what opportunities they may come across. So the wider you spread your net, the more opportunities you can find.
Definitely. And I think that's great advice for anybody that's looking to dive into this industry or has an interest in it, for sure, that the network is a big piece to that. But speaking of those interesting technologies, let's start by talking about in silico medicine. So what is that? How do you describe it? And what's it good for?
Yeah, I guess there are. I'm looking now for an official definition, but I think it's a discipline that encompasses the use of computer simulation in all aspects of prevention, diagnosis, prognostic assessment, and treatment of disease. So for me, my take home from that is where you're using computational modeling, simulation on a computer to understand something to do with medicine, whether that's designing something or looking at how well it works, or diagnosing something within a person, or analyzing treatments and assessing those. It's a great big field that covers pharma as well, I suppose, as well as medical devices. But we are quite focused on going from image data into models to simulation, so that we're sort of in our lane within that already. But I find it fascinating.
So taking patient data like CT scans, things like that, bringing them into simulations and evaluating performance of the device, is that kind of the flow?
Absolutely. Yeah, taking CT, MRI, so you can build up your 3D model from that, because it's kind of like bacon slicing a person and then putting them back together. And you then turn that into a model in a form that your traditional engineering software, your Answers, your Abacus, can understand, and then run your simulation. Bring in your CAD design, change it, see what difference it makes. Is this implant too big? Is it too small? What difference does that make to how likely the bone is to break, or how much range of motion you can get from this particular implant? Or if you're looking at something that's around the heart, maybe you're looking at the impact on flow or efficiency of the heart pumping. You can go into all sorts of detail. There's the scope of engineering software is huge and incredibly powerful, and harnessing that to make a difference to a person, whether that's solving an individual problem because they have a very unusual pathology or a particular problem, or whether that's looking at populations as a whole and understanding what the trends are. You feel like this is really making a difference, and it opens up opportunities where you couldn't do it in person. You can't take someone off the street and put an implant into them and see what happens. So there's a lot of opportunities for understanding those differences that computational modeling really, really allows. And it's the future.
And what are the advantages? You mentioned, obviously not being able to plug it into people randomly and see what happens, but compared to the traditional routes of medical device development, where are the big wins for in silico medicine?
Cost, time, and innovation. I think they're your three headlines. So it's so much, like if you're trying to do a clinical trial or an animal trial, the cost of doing that it's pretty high per go. If you like, where it's within a simulation, you can run it multiple times, do lots of variation, and you're comparing apples with apples, not apples with pears. Where you would be if you're comparing different people. So the time it takes, you can go through your devices, you can weed out your devices that are bad designs much quicker. You see them fail much quicker than going through traditional bench testing, animal clinical trials. And then your innovation, it allows you to understand your outliers better. So rather than hoping that in your cohort of people you're looking at, you have someone who is a particularly short or particularly tall, you can create someone that is that demographic and understand them. And that goes off into whole sorts of complexities when you look at different pathology, underlying illnesses, all these factors that you can take into your computational model that just isn't possible in a real world scenario.
And this is all very near and dear to my heart. This is, I've been involved in on the computational side of medicine for 20 plus years. So I'm really resisting the urge to get into the weeds of things that that there's only 5 or 6 people in the world that care about, right? But before we get to that point, I wanted to bring Kerim in on 3D printing, which I think is another area that we see a lot of changes in the medical device industry. So I think they have a lot to do with each other in terms of, there's a lot of overlap between, evaluating things on the computational side and building them up in 3D printing. But what are your thoughts on how that all goes together?
Yeah, well, I mean, so it's kind of neatly divided between Becky and myself. Although we both have similar backgrounds, we've kind of ended up where, Becky's more focused on the in silico side of things. Obviously, you could tell based on her expertise. And my focus has been more on surgical planning generally. So more personalized surgical planning to specific patients. And how that can look very different and take many different forms. But one major part of that is definitely 3D printing. And, on one side is what you probably see on, TV when you hear about conjoined twins or, a lot of, other types of kind of famous applications where they built a big fancy 3D model of the conjoined twins or of the patient to help them plan the surgery. And so that, although that's where all the publicity is in these very large kind of one-off cases, but you're seeing more and more hospitals within the U.S. I think it's safe to say about there's 400 or 500 hospitals out of the 6,000 in the country, about 300 or 400 or maybe up to 500 are actually doing 3D printing in-house. And that's typically where what we call anatomical 3D printing. So printing the patient's anatomy. So say, the patient has some kind of congenital heart defect, they can get a CT scan of that patient, and the cardiologists and radiologists, they're all very good at looking at the image data. But from the image data, what Simpleware does is we convert that image data into a 3D model. And then from there, you could send it off to a 3D printer. And then you could have a physical 3D model on hand. And what that enables surgeons to do is have something physical and tangible in hand. You can sometimes print the model with similar tissue properties as real life, so they can practice cutting or practice their surgery beforehand. Also, one aspect that at first it kind of seemed as a soft benefit, I guess, for lack of a better term, but it's calming patients down. So and their parents, especially if you're talking about pediatric procedures, is showing the patient, showing the parents the actual anatomy, saying this is what we're going to do, this is going to be our approach. So they feel much more involved in it, and actually the anxiety level comes down quite a bit. And they've been seeing improved surgical outcomes just from that, just from reducing anxiety levels of the patients, of the parents, to help them so they feel more part of the process. And then there's also, medical school education, things like that. So there's that side of the 3D printing, which is, right now they're trying to get it's called a CPT code, which is the code that insurance reimburses procedures or devices for. And it's at a level 3, and it needs to get to a level 1 before it's something like an insulin shot that's readily reimbursable. So figuring all that out is a process that that I'm part of some committees on and that are working on it to bring that more and to help it scale up. Another side is for surgical planning is patient-specific cutting guides. So the idea is that when a surgeon goes into a patient, when they open it up, you develop a guide that you put on the bone. Let's just say it's a knee implant or something. You put it on the bone and it says, cut here, drill there, and you just basically follow the template. So something like that just speeds up surgeries enormously. And so that's another side of 3D printing, where we have customers that use our software, they get the anatomy, and then they design the cutting guide around that, and then they 3D print it, and then they send it to the surgeon with a plan. So when the surgeon opens up the patient, they know exactly what to do, and it speeds along the process. So those are the two kind of main processes we see with 3D printing that we're involved with. And one more as well as patient-specific implants themselves that actually go into the patients and stay in the patient. So those can be things like a cranial plate, or a lot of it is in the head and face is where a lot of this surgery has really taken off. Is patient-specific devices where to replace a jaw, or this, for example, where they'll 3D print the using metal, they'll 3D print it and be able to implant that in the patient, and it stays in them forever.
I imagine that has its own set of challenges in terms of biocompatibility and the manufacturing process of a 3D printed part has different strength than something that you would machine or something that you would that you would cast, I guess. I'm trying to think of all the different ways you'd make an implant, right?
Yeah. So there's a lot of processes that you need to go through, different types of ISO certifications and FDA clearance and getting all that before you can actually implant it into a patient and keep it there.
But what kind of stood out in what you were describing is a lot of that was visualization. Like Rebecca had mentioned early on, kind of the imaging as kind of that bacon slicer, where you've got, slices every few millimeters in your imaging. And it takes quite a bit of training and experience to get to the point where you can mentally kind of assemble that yourself. But what Simpleware allows you to do is to put all of that together into a 3D volume that can be used virtually on the computational side for looking around, manipulating things like that. And then on the other side of that is then to make physical objects out of it for the visualization for people that, like you said, parents of patients themselves to be able to actually hold it in their hand and say, this is a 3D printed version of your heart, and this is what we're going to do in your procedure, and that brings a lot of confidence from the patient side, reduces that stress and things like that. Does that sound like the visualization part of that is kind of a key component?
Visualization is great. It's one of the cool things. You can sit for hours and look through these images and spot little things and spot details, and it's really amazing when you start segmenting structures out, and suddenly, you're looking through your bacon slice images, which, as you say, just 2D at one slice at a time, and suddenly you segment the structure out and it appears as a volume, and you understand how that shape is in 3D. And when you have sort of deformities, differences, you can then really understand them compared to using sort of X-ray or traditional 2D imaging that people may be more familiar with. You can see how that shape is wrong in not just an XY base, but in your whole 3D sort of deformation, your contours, and seeing how something twists and defines. And for a surgeon, that's really valuable. You can see how you will have to approach this problem in 3 dimensions rather than thinking of it as planes. And that can result in avoiding all sorts of problems. But some of the cool things, new technologies we've got, things like looking at 4D heart CGs, so we can bring in those data sets, and then you actually watch the heartbeat on the screen. It still blows me away. It's just amazing.
That leads to my big question, which was what's an application of this that has truly just blown you away in terms of an application of the software or an end result with a patient, where you really did realize that this is making a big difference for patients?
I mean, a big recent one, which was we work with Nicholas Children's Hospital down in Miami, and actually their marketing team's really good. They made a video of this one recent case. It's called Roy's Story. You can Google and look it up. And it's just a little boy who had a tumor in the side of his head, and and they used our tool to look at the image data and generate a 3D printed model of his skull with the tumor and put that in the hands of the surgeons. Also, they were able to use augmented reality lenses and take that same model and put that into augmented reality, and the surgeons could, collaborate looking at this model in space that they see through their HoloLens and glasses and plan for the surgery. And just seeing, just the way they showed the whole picture, because we only see snippets of it. We see, image to model. That's what we do. And then if we're lucky, they'll show us the print that they made. But seeing kind of the patient side of it was really nice to see, the impact, and having parents, who are, just like I would being a parent, you'd freak out if your kid was going through these procedures and surgeries and things like that. And just to get that comfort and understanding and confidence in kind of the medical team that you have to do this procedure. That was pretty remarkable for me. I mean, it definitely got me choked up, especially now that I have kids, just thinking, going through that process, I couldn't even imagine. So seeing that kind of application is it's really nice.
And we'll get the link for Roy's story and put that in the show notes for sure. So people can see that firsthand for sure. So what about you, Rebecca?
I'd be thinking, I think one of the really cool things I've seen is people who have had significant areas of bone lost to tumors, cancers, trauma, where suddenly they've only got fragmented a little bit, like a jigsaw with half the pieces missing. And that the ability for engineers to design these sort of implants that are like, they're like very fancy Meccano in some ways, and they build together these structures that allow them to hold the pieces of their bones back together in roughly the right place, make use of what's left, and fill in the gaps, and give them back the ability to walk. These sort of things are incredible, and it just makes me happy that I live in this age, that we can do things like that.
Certainly an impact for the quality of life for someone that is already, dealing with, like you said, cancer or some other trauma, that 20, 30 years ago, this wouldn't even have been an option.
Nope. They would have had to have an amputation or be bedbound or wheelchair bound indefinitely, and this gives them back the ability to move. And the innovation for that, and the ability for human ingenuity to find ways to help other people is really lovely to see, heartwarming.
That's fantastic. Yeah. So shifting a little bit to kind of your partners that you work with in terms of, or that are developing new devices, are designing new implants, things like that. Are there common misconceptions that you would want to clear up with folks before you ever kind of sat down and worked through kind of a workflow that would include Simpleware and things like that? What sort of things do you find yourself explaining over and over again that from a technical standpoint for either the engineering staff or other people that are involved in the development of those devices? Where are they visualizing this wrong, or how would you change their approach if you got to wave them at the magic wand?
I don't know, Becky, you want to take this one?
No.
I can start. No. Yeah, so I think with definitely, being on the sales side of things for so long, you definitely see some misconceptions and false expectations from customers, and especially on, I think there's a misalignment in terms of the perceived amount of effort that goes into doing a lot of this modeling, and ways that it can be improved and scaled up. So recently, and I would say the last 4 or 5 years, right, Becky, we've been focusing, we've been doing a lot of machine learning based artificial intelligence and leveraging that. And it's a big buzzword now. It's on the top of the Gartner hype cycle. But but we've been leveraging that a lot to, in some cases, almost fully automate people's workflows. But to do that, you need scale, you need data, and you need to have a good, solid understanding within your team of how to process that data and what it means to leverage machine learning based AI. Some customers kind of feel that it's just something it's just a magic box that can be done. But the amount of understanding that it takes to build these solutions is significant. And, we always regularly run into customers who say, well, there's open source tools. Why can't I just do it myself? Or, they get from their executive say, well, let's just build it. We don't need to buy it. And just getting them to understand, without being viewed as a sales guy just trying to close a deal, but getting a realistic understanding of the type of investment it takes to do this in-house. Certainly there's plenty of customers, plenty of companies who are doing it in-house. And, when you pull away the curtain, it's always kind of interesting to see who's really been able to do it versus not. And who's got, and you get a sense of kind of the corporate structure of how they view this technology. And some customers, yeah, blows me away. They're doing a great job. We're like, you know what? You're good. We'll move on. You know, whereas with others, you see it and you think, oh, this is clear to regulatory, you know, and guiding them back to the right path of how to properly leverage this technology and then deploy it efficiently. So that's something we work on. It's kind of nice about being part of Synopsys is because they've been around. They've been in Silicon Valley for 35 years, which is ancient by Silicon Valley standards. And they really focus on building relationships. I mean, we're a tiny, tiny part of Synopsys, which is a much broader company, but they really focus on building long-term relationships with their customers and really providing the solutions they need. You know, and so that's what we've been really focusing on is building those relationships, building that trust, and working with them to make them understand their own data, understand their process better, and really automate it. Because typically it's, you know, people know what they want to do. A lot of these workflows we're talking about, people can do it. It's just you need to be able to do it efficiently, quickly, and accurately in order for it to be relevant. You know, if you're talking clinical, you don't have 3 months to build a model for a patient. You know, they're sitting in the bed right there. So what we bring to the table is automating that stuff and making it more efficient and making it more deployable and scalable for people. And so for us, it's coming back to your question of kind of the misconceptions is building that trust with the customer over long term, and that we're in it for the long haul, because these workflows aren't overnight. They take time. But once it gets built up and deployed, you really start seeing the value. One kind of funny side note is when we first started doing these AI solutions. So I don't know if we explained it, but when you get an image from an MRI, there's a process called segmentation. And so that's when you're extracting the geometry. So the most manual way is you go in slice by slice and you draw it pixel by pixel. There's ways to, kind of automate it, but it's a manual, it's a labor intensive process. And with a lot of these companies, they're getting patient data, it's coming in, they need to process it, segment it, and then do their surgical plan and send it back to the doctor. So they're doing it manually, so it's teams of people. So with one of our customers, we were deploying an AI solution that basically automated the whole thing. And I kind of felt guilty visiting them, thinking, oh, we're taking away these engineers' jobs. But in reality, they were thanking us because nobody likes segmentation. Nobody likes doing this manually. So now they could actually work on much more valuable tasks and just do more. So that was kind of a side note, a tangent from your question, but it was kind of a nice way to deploy this. There's a lot of hype about AI taking our jobs, but it's just enabling people to do more.
Yeah. So it sounds like those efficiencies are a big part, that you really have to keep your eye out for places where you can deploy, say, Simpleware to gain those efficiencies, open yourself up to doing other things. And it's not just about, buying another license to another software set, that there are real advantages to being there. So I think that's certainly a fair point to make, as people are looking at new devices and new workflows and things like that in order to get where they want to go. So.
It's always a bit of a chicken and an egg. Sorry, Becky. It's always a bit of a chicken and an egg of, they don't want to scale. They can't scale because they don't have the need, and they don't have the need because they can't scale. So it's a bit of a chicken and egg, but, we have those conversations all the time, and it's just about figuring out, is there a way that we can work together, and having those kinds of higher level conversations without worrying, are these people just trying to sell me something?
Rebecca?
I think I'd pull back to a slightly higher level, my comment on your question that was a while ago now. But
yeah,
I think on a very high level, rubbish in, rubbish out is something that I remember being taught at grad school, and is so true. If you have imaging data coming into you that 5 mil, 10 mil slices, you're not going to be able to correctly identify and measure a 1 mil feature in that. It's just not possible. So sort of having that understanding of what your data is and what is in it, but it can work the other way too. Sometimes people completely underestimate the amount of information they can get from their data, and also the amount of things they can do in a tool. So they will learn, they'll pick up a tool like Simpleware for one small thing, and then they'll just do that, and they stay blinkered to it just working in that area, and they won't look beyond and see all the other things it can do that could solve more problems for them. So I think, in terms of advice and misconceptions, it's, be realistic in what you've got in front of you, but also keep your eyes open and look and ask questions. Can it do this? Will it do that? And suddenly you'll find that it's going to open up a huge amount more than you think it could do.
Yeah, it's very common for me to come across people that they're after the conversation, their realization is that it's not as complicated in some cases to do the things that they want. I mean, that there's entire industries of people that have worked in those spaces to make those things go easier for them, and things that they assumed were just too complicated to even model, to simulate, really have been addressed over the last 20 plus years, and a lot of progress has been made. And of course, on the computational modeling side of things, the computer speed has taken off as well. And every time that doubles, it opens up new space for new applications, better fidelity in the models and things like that. So it is definitely a moving target along the way. Things that were impossible to do even 10 years ago are now very commonplace.
Absolutely. I mean, we have a team of developers that sit there. They're not twiddling their thumbs every day. They are constantly evolving things, moving things forward. And if you've not got the latest version, or you've not bothered upgrading, you're missing stuff. There's a team of people adding value, and the things that they add are the things that we hear people want to use and see. So keeping up to date is, it is a bit of effort, actually, especially if you've got several different softwares to keep on top of, as well as keeping on top of the literature and understanding what your competition's doing and all of this. But it's well worth it, because it will open up opportunities, and there may well just be a button that does what you want to do.
And my last kind of question as we wrap up here, Kerim, you and I have come across each other at many different events, different standards committee meetings, all sorts of places. So my question to both of you is, how important is that connection? I know when we talked about networks very early on in terms of developing those when you were in grad school, but as far as a career in medical device development and the space that we're working in, how important is that connection, and why put forth the effort to be on those committees, to be present at those conferences, on podcasts, that sort of thing. What's the benefit? Where do we go from there?
Yeah, I mean, to me, network is everything. It's very important. It's just the more people the more you learn. I mean, it just makes also, part of our jobs is you kind of get siloed. So it's nice to go to these conferences and you meet people and talk to people about different ideas, different applications. It kind of keeps the tank full, in terms of motivation to keep moving forward and keep learning in these areas. I mean, that's why I love my job, is because part of my job is just learning and keeping on top of what we're doing and figuring out what people need and how we can solve that problem, and communicating with different people, with internally and externally, and being part of those committees. The FDA, the V&V 40, so those the committee on computational modeling for medical devices. I'm on the Radiological Society of North America 3D printing special interest group. There's other groups that we're part of, and just going to these conferences, it's nice. Also, our competitors are there, so it's a non-competitive space, so we can, your frenemies are there. You can hang out and chat about something common without worrying about, are we talking about anything competitive? So it just kind of builds that community, and also that sense, especially in our area, where it really is rising tides raise all ships, because the more people you can get doing this, the better it is for everybody. And so meeting these people and being part of these committees, going to these conferences is very important in terms of personal and also professional development.
Absolutely. I think if we sat there coming up with ideas within our four walls, and we go, this is great, we love this, this is really, really useful. If you don't go outside and meet people and talk to them and learn what the genuine problems are in the real world, how do you know you're developing the right stuff? And the more people you meet, the more likely you are to have that conversation that really sparks an idea that goes, oh, that's the solution, that's the problem that we need to address. It's those kind of forums where people, especially the committees where people are talking openly, that you really get that sense, and that could be your next big thing.
Nice. So people listening to podcasts find out that Simpleware might be something that would be useful for them. How do they get a hold of you?
Pretty easy. You can email simpleware@synopsys.com. That's the easiest way if you want to get in touch with us. And yeah, we're always interested to chat with people who have any interest in these kinds of applications. Yeah.
Well, I'd say if Synopsys is spelled wrong, it's not spelled with an I, it's spelled with a Y. So if anyone Googles, you need to remember that.
Yeah.
Very nice. Okay. Well, thank you both for being on today. I think we covered a lot of ground from training to technology to kind of misconceptions in the industry as well as the importance of networking. All of this has been great stuff for sure. So thank you both for taking the time to be on today, and we'll be sure to include that email link in the show notes so people can get a hold of Simpleware as needed. So thank you very, very much.
Thank you
very much.